All right, so let's get started. So thank you for coming to my talk, and thank you for having me once again here at Vox Day Zurich. It's a beautiful country and a beautiful community here, so I'm really happy to connect again. And yet again, about open source and JavaScript security. So hope we're going to push it up a notch this time with more live hacks and how the application is actually a bit bigger in terms of the attack surface than it is today. Before that, I'll introduce myself shortly. My name is Liran. Flew here from a couple of other events, but I'm originally from Israel. I am a developer advocate at Snyk, where we basically build developer-first security tooling, so everything that kind of like helps you out as a developer to fix security issues, automate the whole thing from IDE to CI/CD and production. It's kind of like the bread and butter for us. Aside of that, I am active on a bunch of communities and foundations like Node.js, OWASP, GitHub, and others around open source, just promoting awareness, promoting education, writing content, chatting up with all of you great folks here, and essentially just trying to do more and better for the JavaScript security and the Node.js landscape as well. So if you have any questions on any of this, feel free to reach out. I do think we're not seeing the slides at this point, so I'll go ahead and do hello, no slides. Hello, no slides. This is part of the security talk. I basically just put an invisible. Yes, there we go. That's it. That's an invisible backdoor showing up there. You can't see it. I don't know if it's not. All right, cool. Please do. Yes, everything is connected here as well. I will double check mirroring, but let's do the whole thing that they taught us as engineers. Restart. You can tell them that I turned it off and then on again, and it didn't work still. So cool. We can use this time until we get the slides back if anyone want to share any recent story they heard about security recently. Just shout it out. Did anyone here hear about this little thing called Log4Shell? All the Java people are like laughing, and all the JavaScript people are like, what? What is this thing? I do not know an NPM package called Log4Shell. Who heard about Node.IPC? I can't see anyone, so you have to like shout, like, yay! Yes, okay, cool. Okay, that's also good. Okay, it did work before, so I don't know what's going on.
Okay, you tested?
Yes.
HDMI directly is connected?
I think so.
Now it works.
Okay, great.
Sorry.
No, it's all good. I am not going to do the whole intro again. So you'll have to like do the whole recording of the video afterwards, the edits. I'm sorry for that. But welcome to my talk, Stranger Danger, JavaScript Attack Surface, and myself. So we'll skip that and talk about the cool stuff, like what is the future of open source security? What is it? And I actually want to put this out there, and there's many answers, and people have different opinions. So keep that in mind. Where are we going in terms of open source software security? And we'll see where that takes us through this talk as well. So if you're coming from the NPM ecosystem, I know some people are like very diverse here. Some do Java, .NET, different things. But I'll focus myself on JavaScript, although most of these attacks, all of the attack surface here is very much applicable to anything on other ecosystems, as we've actually seen through different incidents. But again, if you're doing JavaScript maybe for the front end, you might have been able to see some headlines around typo squatting attacks. Essentially, just like domain swatting, someone takes this package called CoffeeScript, which is an old framework, so don't use that anymore, I think. But if you are, which is OK as well, and you've misspelled it, you might be getting a package that you did not anticipate or expect to get, which is a malicious one. This doesn't exist on the ecosystem anymore, but this is a misspelling of the package, and it's really, really hard to see. So it takes us into this route now already into what is software supply chain security. This is one example. Here's another one. Just a malicious package doesn't have to be typo squatting to anything else. There's this Fall Guys something, a game. Someone might think this is an SDK for it. They'd install it. This is a real package. All of these real cases from these slides really happened. And so this, if you had installed it from, say, a Reddit, maybe comment or someone that tried to target you as the person to install it, again, would have been targeted as a malicious package victim here. We also have cases of compromised maintainers, meaning me or yourselves as maintainers of open source packages, you are part of the health of the package. So if I am able to do an account takeover for your package, maybe that's event stream or Express or React, and I'm able to actually be able to create new versions of that and submit them to the registry, someone else just goes and downloads the latest packages, right? And so at this point, the maintainers are being targeted, and we are all part of the supply chain security stuff because we are all part of the ecosystems as consumers. Now, as I said, all of the stuff in my slide are real cases. So yes, someone at one point in time was able to gain access to all of those NPM packages. I'm pretty sure, even though it's a mixed, diverse crowd, some people here know these packages, this small thing called React, small thing called Express. Some of them were malicious attempts, like event stream, like mail parser. Other cases, like Express and React, the person who actually gained access to really publish versions there for those packages on the NPM registry was, thankfully for us, an ethical hacker who was doing research and was able to show how weak NPM credentials allowed basically everyone else, if it was a malicious attacker, that this was their actual goal was to really publish malicious packages. This is what they do. They've actually gained 3 times access to Express, as an example. We'll not talk about too much here about two-factor authentication and all of those really good security hygiene, but I really recommend looking all of these things up because we are all part of this ecosystem. So our software supply chain security really starts here. But it's actually a little bit bigger. It's more than just the malicious packages, the compromised maintainers, dependency confusion, everything else that we're seeing on the registry. It's actually more vulnerabilities for us to also consider, but not really just on what we thought is the application. You all are thinking application, you're thinking IDE, I write code, this is my app. It's a little bit more than that, and that's what I think we'll get to here. So it's going to be a bit of a live hack here. We're going to be able to hack a live application built with Node.js. We're going to hack it based on the fact that it uses a vulnerable open source package called Mark that does a markdown. But then we're going to actually containerize an application, and due to the fact that the container may have vulnerabilities, we'll see how it's possible, unrelated to the Node.js app or the dependencies in the Node.js app, we're actually able to leverage the fact that the container was actually built insecurely. We'll see why. And we will get into this. Lastly, I don't know how many people are doing here Node.js active development, but if you are, for example, Electron and other cases, as was presented here before, if you have Node in production, most of the chances I'm not even sure if you know which versions you're running or people in your team, just use LTS or whatever, long-term support for Node.js. Now it's 16, tomorrow it's 18, and so on and so on. But which version in particular? Maybe you know that because you want to specifically use a package, a version of Node, which has a specific feature like supporting ESM and different other kind of experimental, integrity policies and stuff like that. So these are the driving reasons for you to choose specific versions of Node, and this is how you become aware of it. But in fact, Node as a runtime, just like every other runtimes, may have vulnerabilities in the core project, which is something that developers do not think about too often. And so we'll see at the last hack how we're actually able to now, besides open source dependencies, besides the container, the fact that the Node runtime is vulnerable, what kind of exploitation we can do to actually hack the app. So, kind of want to thank you here for being on this talk, because it means that you care about software. It means you care about open source software and about open source software security. And I really, really value that. And thank you for coming and spending the time with me. And I think we can all acknowledge the fact that open source security, but not just open source, but application security in general, it's really hard. It's very challenging because no one teaches that officially, right? learning software development concepts in university, in CS studies and stuff like that. But it's mostly the foundations, the basic, the algorithms, the things that are important, that's true, but they're not everything about software development. We're probably not being taught too much how to write tests or how to write them well, how to do performance testing, how to do benchmarking, how to do accessibility if you're building web applications for the front end, how to do security well. We're not really taught that in any official manner most of the time. And so application security, that's why it's really hard for everyone else, because we have to go above and beyond to really learn and deal with it. But we can't forego this thing, because this is part of the quality of the application. And so it's hard, but let's see how hard it is. I've been here before at Vox Day Zurich in 2019, and I talked about black clouds and silver linings in Node.js, and talked about everything that was up and coming on the Node.js security kind of like aspects and so on. And in that talk, I actually talked about several things, like regular expression denials of services. We've done a live demo of like NoSQL injections and different kind of things. And I'm coming back here with a similar vulnerability and what really happens, even after that talk. If some of you recognize this, you could probably see this as a middleware signature function for the Express web application. It's essentially, it's real code. It's just like a bit diminished. So this is not pseudocode. This is actually JavaScript. It's beautiful. But aside from that, you can see it takes a request, response, and next objects. And what it does with them is run a SQL query. It checks for users. It compares the username and the password from what it received from the request, and goes off to run some function. You might think of it, potentially this might be maybe an SQL injection, but this is a NoSQL database. So what's really going on here? Because if I'm trying to concatenate string as the username or the body, regardless of other issues that exist here, because this is like plain text and not hashed passwords and stuff like that, it's not using any strong cryptographic hashes to do it. But besides the fact, this is still an issue here. But it's not an SQL injection. It's a NoSQL injection. And the reason for that is because most, probably 99% of web application in JavaScript, or Node.js specifically here, that use Express, they actually use this body parser middleware, where it allows you to take JSON that has been sent in the request body and transfer that into first-class level citizen in JavaScript as an object. And what that means is then what we've seen here, request.body, actually means I can access body.password.something else nested in the JSON. That's really convenient, really, really convenient. But it's also the source of this, a NoSQL injection, which means that if you're using MongoDB, for example, in the backend, specific versions of this and that, and it actually takes specific operators, language operators, like greater than, like less than, like comparison, like while loops, like where, and then a JavaScript statement. I can actually access and query documents based on different operators. And the moment that input now requests that body, that password, is an object and not a string, this flows directly into this app. Now, surely you would say, okay, SQL injections are nice. NoSQL injections are pretty fun as well. Nothing new under the sun, essentially. You sanitize code and all of that. I would say I agree. This is pretty classic stuff when you come to application security. You learn about OWASP top 10. You'll probably encounter this. I totally agree. But the reality is a bit different. Here's an application, a project open source called Rocket Chat. It has actually a company behind it. It's a commercial body. They have 12 million users in over 150 countries. They've actually monetized and commercialized the whole open source project into something that they sell, which is amazing and beautiful story for open source, right? But my talk about this thing of NoSQL injections was here 2019. And this vulnerability has appeared in Rocket Chat, where many people look at it, review it, contribute to it, and maintain it, probably very, very talented developers, in 2021. As you can see, we have the exact same pattern. This is a NoSQL injection attack or a vulnerability that could be weaponized as an attack for this project. You can see the same pattern. Users that find something as a key, and then the value is params, meaning it takes it from the URL parameters. That flows directly in here, and that is potentially a NoSQL injection. That is actually a NoSQL injection. There are scripts outside that are proof of concepts and exploitation that weaponize this. So potentially for organizations who use this software and have not updated or realize that they should, they are now vulnerable to this, and this can be weaponized against them. If you look very closely at the fact of what we're saying here, this is part of the get password policy, which means that furthermore, this is an unauthenticated NoSQL injection. So I do not even need to have an account on this Rocket Chat server to even exploit this. I can just send in unauthenticated HTTP requests and get in or pass in my NoSQL injection. So this is just from last year, and these are things that are still happening. It's just one more example to show us application security is really challenging. It's really hard to get right. Hopefully, we're going to learn a bit more about this today. So 80 to 90% of our code bases are open source. You probably know this. And so when we're thinking about writing code and like what is the importance of open source security, it's the fact that beyond the code that we write straight up on the IDE, there's like a lot of use that we're doing, whether that's POM files and all of those packages we're bringing in from Maven, but also everything else from other ecosystems. If you're a JavaScript developer, you've probably done npm install at once and got like a million high vulnerabilities results, which kind of rendered you like, again, which I agree. It's somewhat frustrating if you have no tools like really be able to prioritize, understand context, and all of those things. And the bad thing that's going on here is essentially it might drive you towards a path where you ignore them, which is not something you want to do. But I totally understand the frustration that's coming out here in terms of we always get vulnerabilities. What do we do about them? So let's see how those vulnerabilities flow into an application. But before that, a little bit, here's another example. This is an open source package. It actually has escape HTML function, but it's not done in the proper way. So I could show you this hack again as a live hack too, and it will show you how an application would actually be susceptible to code injection, not because of the application code, but because one of the libraries that are being used actually have this code injection vulnerability. So while it seems you want to ignore those vulnerabilities, please think twice before you do. So as we're thinking about the writing code and we're moving on with this concept of like why this is important, we write our code to, as I was telling you, I want to use marked as a markdown parser for our examples here, so I'll use it. And I'm thinking about it, and all the time I'm thinking, hey, this is my code, this is my on IP I'm writing this. But essentially my application is probably a bit bigger than that. It's really my entire application surface, right? All of those dependencies that I'm actually now bundling with my application, and they are all part of the source code of the application that gets shipped to somewhere, production, staging, wherever that is. And so developers probably know about ecosystems trends, right? NPM is growing time to time by a lot. It's probably about 2 million packages at this point. Maven as well, like ecosystems are growing. This is really great for open source, but this graph you already know. You would have told me this by heart if I had asked you, does open source grow? You would have said, yes, of course. All of you do not need to see this graph. This one is another one that you probably wouldn't want to see. And that is the trend of vulnerabilities increasing year over the past about decade that we find in open source. Because it makes sense. More people use open source software, so more people, security researchers as well, will take a look at what's going on in open source packages, and more vulnerabilities will be found. As we're seeing day to day, we just talked before, right? Log4j, Spring4Shell, all of those kind of things. NPM as well. Ecosystems are not hidden from this. Security researchers understand this, and usually when ecosystems are really small in vulnerabilities, that's simply because not a lot of people have actually looked there. That doesn't mean that they're clean of it. So that's a whole different discussion of like which application ecosystem is probably more secure, but I will defer that to the hallway talk afterwards if you want to talk about it. So bringing us a bit back in terms of like that path of open source supply chain security. We are dependent on this ecosystem. Event Stream, which was happening back in 2018, was an interesting story of how one developer, actually a maintainer of this Event Stream package, which probably I didn't know about it before, probably a lot of people here didn't know about it either, because it was usually a nested dependency, but it was downloaded millions of times, and it existed on the ecosystem since 2011, which is like the birth of Node.js and the NPM ecosystem, the very beginning of it. Existed for so long, but still, the maintainer here, was kind of like burning out. They had a lot of other packages and different things to do, and someone was able to socially engineer their way to get access simply by trying to be a good person, like trying to open issues and fix bugs and open pull requests and merge them and all of those things. And this person, the maintainer here of event stream, trusted them, but they essentially used that trust, abused it, because they got access to the repository and to release new packages. And so they added their own malicious package as part of that dependency tree. So every time someone installed event stream of a specific version, automatically that new malicious version would be taken as well. Now, this is a story that the attack itself is super interesting, and I highly recommend reading the whole postmortem here. It took about 3 months for all of this thing to unfold until someone found out about it, and even then it was by a mistake, because part of the malicious code was actually throwing some console errors when you install them. So even that was a mistake, and we did find it, but the person that actually they targeted, those developers of like a Bitcoin crypto wallet application, they actually were targeted, specifically them. And they did end up releasing 2 vulnerable versions with the malware inside from this exact case. So this is very real, and it's happening all the time. We're just hearing about it afterwards. So I would imagine and want that we would be doing a better job in terms of our way to vet new packages. This is an example if I want to use Moment. I actually do not want to look at the package just because it has downloads and it has a lot of stars. That is the stars currency, the downloads currency. That's kind of like what we used to use as a proxy of whether this package is good enough or not. But essentially, there's like a whole set of health signals that we should look at. For example, what's the maintenance like of this project? Like, this is unrelated of security. If I use this today, tomorrow there's going to be a bug. Is there someone going to be there to fix it? Is someone going to be there to merge my pull request if I want to help fix it? I don't know. You have to check it out. You have to look at all these aspects, because we understand that we're all using open source software to build our products. And so this is more than just vulnerabilities. This is more than just SBOM in all of those cases. This is really about the package health. Making it a bit more complex is the fact that those application dependencies, when we find vulnerabilities for them, they actually are found in different areas depending on which ecosystem you're on. So for example, if you're doing NPM, Java, or Ruby, you can see most of the time when we find vulnerabilities for users, when we report those vulnerabilities, they're actually happening in indirect dependencies, meaning you, as developers, have less control of mitigating that vulnerability because of the nested dependency chain. It is a bit different in terms of the ecosystems, how POM files work versus log files in NPM and so on. But essentially, it means we have less control of this, and these are stuff that we kind of like see less often, less direct dependencies. So here's an example. We're going to start with our live hack just momentarily. I'm basically going to imagine that we're going to build this to-do application, which has an input field, which is always useful for a nice hack. And we can put anything in there, and let's see what happens in our application and how vulnerabilities actually transfer to the application to the vulnerable dependency from the application itself. So to do this, I've actually looked at the code base of this marked dependency which I use, and that's like a dependency that has 4 million downloads a month. Like, that's not a small dependency. That's like very, very popular around developers. And it has this specific way of handling links. So if I give it this kind of input, which is a markdown link, and I try to inject something like JavaScript alert, which is very viable proof of concept here, what happens is it goes through this function. This is the code for that version that's vulnerable of marked. It has a link function. It takes the href. It goes ahead and has an if case to check, well, if something here is beginning with JavaScript : or for the old timers here, and I'll include myself there, VBScript as well. So if that's part of the beginning of the payload, well, I probably want to sanitize it. So it's it's kind of like breaking it, breaking the whole string apart and returning null. So we'll see how the app reacts to that. So this is one way that actually sanitizes that. Like, it has built-in sanitization against those things. But also it has something else which is pretty interesting. If you try to escape the colon in different ways, which is what hackers usually do. They try to represent things. For example, if you want to do path traversal, you might try going in curl domain slash dot dot slash dot dot slash and escape to the root directory, right? But if dot dot is actually a string that gets sanitized, you could actually replace that with %to e, which means, hey, I'm actually going to try and escape it, and maybe the app isn't actually treating with these unescapes. And so we see that with marked, it does actually have an unescape function. So it's actually the maintainers here have actually thought about all of those cases that someone could actually hack them, but still it was vulnerable. Go to the unescape function, you could see it actually has a regex that attempts to find all of those HTML entities that we'll see in a second, and filter them out as well, so you can't hack it. Now, the moment that you see a regular expression, what do you know? Well, basically nothing, because it's not readable. But let's talk about it in a second. So let's say that this is our application, right? We essentially want to be able to get those automated upgrades all the time, so we don't have to look for them. So whether you use Snyk or something else, you still want to automate that whole process, because essentially for you, if you need to mitigate a vulnerability and you just need to upgrade the package, that's like the least amount of work that you need to do. That's great. That's like putting security automation in the hands of developers, which is exactly what you want to do, because you have the context. If the upgrade is from one major version to the other one, you know to look a little bit deeper inside, understand what's the changelog, and that it's not breaking an API, for example. But you have that context as a developer, so you want those kind of tools. So how is the application actually getting a bit bigger? And we'll talk about this in a second. Right now, I've imported the application. There are some package JSON have like dependencies in it, so I can actually look inside and go ahead and scan it, see what we find, vulnerabilities, let's say. So off we go to, there we go. You just said it, so this is good. So my application is called Goof. I've got this package JSON file here, which when I import this as a repository, I just go here, add project, GitHub, whether that's a fork or whatever, I can just import whatever I have, and it automatically detects a set of manifests that it can tell me something about. In my case, it's a JavaScript and Node.js application, so I've got package.json, and it found all of those dependencies, which I can go ahead and represent as a tree, which is a bit nicer to understand like how things actually flow within the app and what really depends on what. But I can go back into the issues and see that I have a bunch of vulnerabilities here. Specifically, I'm using marked, and even marked, my version here, has several vulnerabilities impacting this application. RDoS and XSS and several attack vectors of XSS. Like one time it was discovered, then fixed. But then another vulnerability was discovered of XSS that the fix before didn't fix it. And so it was fixed again, and so on and so on. So you can see how challenging this is. Even fixing vulnerabilities with the context that you have as a maintainer is really hard. So let's go and understand like what's going on with the app. So this is our application. This is basically vanilla JavaScript and Node.js. What we have here is the app. I'm using marked. You can see it here. And I'll make this a bit bigger. Shout out if you can see it at the end, or more bigger. Good? OK. So we have marked here. I'm using it, and I've gave it even sanitized true to make sure that it actually sanitizes it, and it's then being passed into my application views, my locals here, which I can open this up and show you in the views. So this is the view. It's plain HTML, but I'm using the marked up here, new string, to do content, and that is how I'm bringing the content into the page, into the HTML. So let's go back here, make sure we run the app. Let's see if it's running. OK. It's a bit bigger. OK, so it's basically just a to-do application. I can put everything here like. OK, we'll skip what I want to say there. But you get the point. So input. Input is important. User input. People can do things with it, like this. right? This turns into HTML. I can use Markdown to HTML and build really cool things. I just need to use an open source package like Mark that does it. That's pretty cool. Also go ahead here and do JavaScript alert, because I can actually pass JavaScript alert as the href value for the HTML element here. And when you click on it, like if you actually wrote that yourself, not as a user input, that would indeed pop up the alert. But that doesn't work here. You've seen why it doesn't work. We looked at the source code together. We looked at it. We saw there's like a link, and escaping from it, even an unescaping, meaning if I go ahead and try to unescape this, because I know we've seen the regex. The regex code actually searches for, it wasn't even the regex, it was an index of, actually checks for everything that starts with JavaScript, and then it wipes it off, right? That's what the if statement was. So we can go ahead and say, well, you know what? I'll represent colon in a different way. And I can represent different strings. I can go ahead and represent this closing tag, if it's looking for it, with its HTML entity representation of what's and a closing round bracket. Do the same here. If we Google what they are, you'll see that this is what you get. So I can go ahead and represent those in different ways and try to trick whatever sanitization logic is there, and maybe we find a vulnerability this way. Almost. Might give up at this point, but security researchers are pretty consistent in their ways. They try different things, and they usually have a bit more information in terms of the context of what usually goes wrong. And interesting in this vulnerability is the fact that this vulnerability is actually partly related to how the browser works and how Marked works. So now that we actually went into providing this escaping way of the colon, we actually have a way in that is beyond the JavaScript colon, and we've now gone into that part of the code of Marked actually deals with the regular expression. So potentially the regular expression might have issues where that shows. So if I put any valid JavaScript statement here, like the word this, literally, like the word document, so any valid JavaScript statement that makes one, what happens is, if you remember how that regex looked like, and that is why I said like regex are tricky, right? It's hard to get them right. You try different times, you don't even remember after a week after you rewrote that, it's in production, and that's it. Besides the regular expression denial of service vulnerabilities that you may have, actually this is a way to escape it, because that regex is written in a way where if I have this string here, it doesn't recognize it, so it doesn't appreciate this to be an HTML entity. So it doesn't do anything to sanitize this. The browser, however, doesn't have any problem with you passing an HTML entity and just missing out the semicolon here. So the browser does whatever it wants with it, which is basically a link. Yeah, I agree with that. So here we have a vulnerability, a cross-site scripting vulnerability where it originated from user input. And if I had found it here, I can talk a little bit more about what happened there. But this gives me more information. This is the regular expression one. This is a cross-site scripting one. And we can get more information about like what is cross-site scripting and learn a bit about it and how it actually happens and so on. But if I want to go back here specifically, understand why is this vulnerability coming up and why is it happening, I can actually expand this a bit and get more information about what's going on. But further out, get different way of this XSS actually manifesting. You can see here another example, right? Different ways of doing this. If we go back into the actual report, I'll show you something that's really interesting about what happens in open source ecosystems. This was discovered back then, and at Snyk, this vulnerability database, by the way, is free. You can always go there and find out about new vulnerabilities. But what's really cool is that we curate them with a lot of this information. So if you go back to the GitHub PR that's referenced here, you can see that this researcher pulled a pull request for this vulnerability back in 2015, meaning he was actually giving us the payload so people can now, hackers can now weaponize this and run this. And we have examples of like why this happened. Since it's a pull request, not just an issue, they actually went in and fixed the bad regex and also added tests for some regression testing as well for us. So this is pretty cool and great. It's like the magic of open source, right? Maybe. This was proposed in 2015. Everyone was very eager on getting this in, right? Thanks a ton. When will this be pulled? Can we merge this and so on? But in reality, this was only merged about a year later. So if you were using this vulnerability, first of all, if it didn't have an actual CVE, which maybe they didn't go into doing one, if you're using some tools that only watch for CVEs, then you wouldn't be able to like see this, which is one problem. But also the fact that you now have to wait. Like, what do you do if you have this in production? Do you move to a different library? Do you patch it? Like, there are different dilemmas of what you do here. So happy to talk about through all of those as well, but afterwards. But this is kind of like showing you a bit of the problem space of open source security. It's like different aspects of security, from malicious packages, compromised maintainers, vulnerabilities that may or may not get fixed, and so on. So this was a nice attempt going into the application. But we said we'll containerize something and hack it. So let's leave the dependencies alone. And I've got this whole app Dockerized. So I've got this Dockerfile here, part of the source code repository. And I'm using specifically a very old Node 6 version. I hope no one here is using that. This is not an example to use this, which has a ton of vulnerabilities, right? And when you're getting all of those reports, like we said with that npm install, like you're saying curl double free, out of bounds, like file, image magic, I have no idea Python is vulnerable. Do I want to fix it? libxml, I have no idea what to do with this. Most of the time, we'll probably ignore them, which is, I understand the frustration of doing that, but that's obviously, again, not a good practice, right? So 1,000 vulnerabilities, that's really hard to triage. Let's see what could go wrong. I'm going to go ahead here, and I'm going to switch to a different container. So this was MongoDB before, which we don't need anymore, and this one either. And I'm going to pull in this other application. I think I've built it already, so maybe we can just run it. OK, so this is this one. Let's pull it in over here. And then we can concentrate on this one. So this is a fairly simple Dockerfile, right, from Node 6. You can imagine we just went back in time, right, to the time where Node 6 was long-term support. It's a fairly simple Dockerfile with many, many issues here. Basically, every line here is bad practices. But for simplicity, this works. So you can see this is a very simple one. I haven't even specifically and explicitly added any kind of package into it, right? This is just whatever I have in the container. Just give me Node 6, I'm good. So I started this off, and our code is also very simple. Imagine this is some backend. It's not even open to the HTTP world, right? It's some backend, job server spawning this off every time there's a new image coming into the queue. It pulls this off of like SQS or whatever you want to use. It does some kind of like a conversion to it. To do the conversion, because I'm using Node here, I know it's single-threaded and everything. So I'm basically spawning off this user bin convert command, which I'm doing safely. I'm using exec files, so no one can add any arguments here that might, give it like escape this and run different command and so on. And it's just resizing it. So this is the whole point of what it's doing, right? Really, really small for the purpose of us. Instead of like building this whole architecture on the cloud, I've just exported this whole thing as this HTTP route. So that's what we get if we go over here. Right, cool. So we have this app, and what I want to do is upload an image to it. So before I do that, I want to show you something else. The app is running here, and I see it actually running. We just started a minute ago. I'm going to go inside the container. As I look inside it, these are the files that I have, right? So the container is running. You can imagine this has been deployed somewhere in the cloud. This is the file system, right? cat server.js. That's what I showed you just now. The same thing. This is actually it. So let's look at the files again, and we'll visit it in a sec. and I want to upload a new image. Usually, users control images, just like they control input, like their email addresses or Twitter accounts or whatever. So I'm uploading an image here, and I'll just do this and resize. And, well, it's not my Yoda hat picture, but it's something else, and it was successfully resized. Well, let's see what really happened when I uploaded this. Go back to the file system here, and now we see something new that's happened. This did not exist before. So essentially, a new file, an empty new file right now, was created on this container, not because of the fact that it had the vulnerable dependencies or insecure code, but because of some other reason. What really happened there is the fact that we have used Node 6, which has an image magic vulnerability. Actually, it has a bunch of them, 252 of them, if to be accurate. And you're right, like if I look at this and I see null pointer to reference, I have no idea what this means or how is this applicable as part of my application. I'm not even using this. Like if you ask a developer using ImageMagick, no idea. I'm just using, convert. I read a blog, it converts images from one to the other, I spawn a command, that's it. Like no user input even flows to this function call, nothing. Well, it has a bunch of other different issues here. One of them is that vulnerability called image tragic, which you may have not realized that it impacts your app, but it does. So the way that it impacts your app is the following way. Remember that MVG file that we uploaded? That's a specific way. I'll make this a bit bigger. That's a specific way of describing images that convert, by the way, and ImageMagick supports. We may have not heard about it, but attackers have because they researched this whole stuff. And it actually exploits a capability, a feature in ImageMagick called delegates. So it allows you to create a file which is kind of describing how the image should be in text, not in binary. It's not bitmap or anything else. It says, push graphic context, there's like a view box, whatever. There's like a bunch of stuff that actually goes ahead and generates this in text way. That's kind of how I described to generate this. But also, if you scroll down to the bottom part of this, you would see it actually says fill some of this part from a different image. But this URL doesn't need to exist. So it may try to fetch it, maybe not succeed because I just tricked it, because I wanted to actually exploit something else in this ImageMagick library. And that is the user input that hasn't been properly sanitized. So I've actually escaped in this exploit image file the command itself that it actually passes then to curl or wget on the container itself. This is how ImageMagick works, how the convert system command actually works. And I've actually said, hey, you know what? Just touch, hi, Voxda is Zurich. So I could have done anything here, like run remote reverse shells, read your environment files and send them somewhere else, whatever. But this example shows us how, again, user input flows through very mysterious ways, like even images and their contents into my application. So this has been a nice and interesting way. And of course, what you should be doing is fix it. And fixing it might be hard. We'll talk again in a bit of what you should do. But we're trying to make it easier for you by saying, hey, you know what? This is your base image. It has 1,000 vulnerabilities. That's really a lot. But if you want to move to one of those, which we've seen somewhat related to yours, this is going to be your vulnerability count. So there's nothing here with a 0 vulnerabilities count, which would have been great, but there's just nothing else that fits it. Still, triaging, starting point from 42 vulnerabilities and not 1,000 is already a great point. We'll talk about it afterwards a bit. But we said we'll also attack the Node application too. So let's go ahead and do something. Let's say that we want to be able to we understand that this ImageMagick vulnerability happened because we used the Docker base image that has vulnerabilities in it, and we haven't built it, haven't used the correct one. So I'm back in time right now. This is Node 6. The next long-term support version is actually Node 8. Specifically at that time, it was Node 5.0. I could have used the Alpine one, but I have right now this one built, so I'll go ahead and build this. Let's, of course, stop this first. So I'm building a new image, moving into Node 850. I've essentially probably have mitigated the ImageMagick vulnerability just because I've used a different base image that has a newer version of ImageMagick. That's the old thing. I'll go ahead and run it. Oh, sorry about that. There we go. So it's running. Application-wise, everything works as expected because I didn't really change anything except running this base of like a new base image, Node 8, which is great. And I can try the whole thing, but trust me on this. This is like have been mitigated. But we have another thing that we haven't maybe considered at this point, the fact that the Node runtime may have vulnerabilities, right? And I can filter specifically maybe for OS packages, maybe for the Node runtime itself, and figure out what do I have. So how does a Node runtime impact my application? Well, first of all, it directly interacts with all of the HTTP or something else that I can like throw at it, right? Like this is the front-facing thing. And what I'm going to do next is show you how it has a path traversal vulnerability in it. So if I go here and do this, curl, there we go. But I'll explain to you what's going on here. So what I'm doing here is I've got localhost 3112/public, which is what we declared as part of this app. Then we're doing %2e, which as we said before, it's basically dot/. So I'm trying to traverse up the tree. I have to specifically, for this exploit to work, to mask it with some kind of parameter name. And then I need to traverse all of them back. So you see dot// repeating 4 times because it actually goes through all of my app directory, which is in this case user/source/goof, and my masked parameter. And if I just do this and can actually now access any file I want on the running container, like etc password, here it is. Like user source goof/server.js. Here it is. My package JSON. Anything else, I can just access this. This is like a real container. The only difference is that this is not deployed on someone's cloud production here. But it is the exact same thing that works. And the only reason that I'm able to do all of that is because I've used Node 5.0. Nothing else in my code or dependencies, or even the container itself, except from the runtime itself, is actually the cause of this. So going back into this, we've talked about all of those, package JSON. We've talked about it's important to do application repository importing and understand that all of our dependencies are having those cases of vulnerabilities that we need to fix, but also something else comes in, right? All of those cloud-native things, like if you're deploying to the cloud to Vercel or Netlify, like a front-end developer, right? But you are really a cloud-native developer. This is like they take care of like edge and caching and all of those things for you. Same if you're a back-end developer, you're deploying all of those lambdas and serverless functions and containers to the cloud. You also have those kind of very important responsibilities as part of your role to understand how you're building your image, your base image, for example. So the missing part here, the bigger attack surface that we've seen, is beyond just the dependencies that we've learned about in the beginning. It's also how we build the base image, what's inside it, what's the runtime that's actually running. All of that really contribute to this. So I'm doing from Node, I may actually import many, many vulnerabilities. In fact, I may be importing a bunch of them because this is by default the amount of vulnerability that exists for different images based on a scan that we did back in 2018 and 2019. So the attack surface is real and it's really happening. We talked about this common surface software that we bring in. If you do it explicitly or implicitly, it's still in. And you might be bringing in dependencies that are vulnerable and the runtime might be vulnerable. So the whole thing might be vulnerable. So we talked about exploiting it and we did all of those things together, which was fun, I hope. But now what can you do about it? So this was the improper input validation that we saw with the CVE. You might have thought, well, is this a real use case or not? Well, actually found back, went in to find an example use case for this, which I would hope is shows you that people actually do this, right? Whether it's bad or right, that's like a different, everyone and their own opinions. But this was the ImageMagick, and it shows us, for example, if I had found it within the Sneak app, how it would tell me which actual command instruction introduced this to the base image layer, and which vulnerabilities I'm actually importing, as well as giving me this recommendation to fix them. But it's really happened. So we talked about your code and your dependencies and understood that the application itself is more than just your code. It's the dependencies themselves, like Fastify and Marked and all of those things. We talked about the fact that it's also the container itself, right? The runtime and what I have. And there's actually more into it. And there was a really great presentation earlier today from Jacob about owning a Kubernetes cluster, which is the missing part here. All of this gets deployed somewhere, and we've kind of used to the fact that we configure our infrastructure through code, right? IAC, and all of those kind of extended to Docker Compose and Terraform and all of those cases as well. And that allows me to also configure how the infrastructure is. But it's not really how the infrastructure actually works. It's also what it may not work well and what I'm not really exposing well. So all of this is really, really important in terms of misconfiguration. We're not going to deep dive into Kubernetes, but it's really important to know. And so just some takeaways, small ones. First of all, connect your source code repository so you can watch all of those. Usually your code base includes your package manifest and all of those other cases of Docker files, etc. If you want to follow some of these best practices, I've actually worked a lot to build some of these, and my friends like Brian Vermeer, Java Champion, and others have been also been working on writing down, researching what are really best practices to do this. You can find all of them if you just Google for this on the Snyk blog. The Snyk Learn is a really cool way of just learning about some of these cases, like how you learn about SQL injections, why do they happen. And that's it. So thank you so much. Hope you had fun hacking stuff. And come see me if you have any questions. I'm here. Cool. We have time for a question, right? No? Time is over? OK, I'm here anyway. So just go ahead, and if you have questions about the big hat or whatever, I'm here.